Hello, this video is going to really quickly go through how to draw linear graphs that are usually in the form y equals mx plus c, so where you can quite easily pick out what the gradient is and pick out what the y-intercept is. I'm going to do one slightly different one at the end, but those are going to be the main focus of the lesson. Obviously, there will be some exam questions where they give you a table of values and it is just a very straightforward fill in the table of values, plot the coordinates and join it up. This is how to draw the linear graphs without using your table of values. Because sometimes that would just take a little bit too long where you need to draw the graph as part of a different question. So if you are having to draw inequalities and shade a region, for example, you need to be able to draw the linear graph or the straight line a little bit quicker so that you can answer the rest of the question and you're not spending too much time, making your own table and working out the coordinates. There are quicker ways of doing it. So the first ones I'm going to really quickly run through are your horizontal and vertical lines. Just to recap those, they are the simplest ones to draw, but they are often ones that people kind of forget about. You want to have to draw something with a gradient and a y-intercept because that's what you've practiced loads, because they're more difficult. So you often forget how to draw the most basic ones. So really quickly go through that. So we've got x equals 3 is our first line that we're going to draw. That means every x coordinate on that line, the x coordinate of every point on that line, is 3. So the only place where that would happen is the vertical line that goes through the 3 on the x-axis. So 3 is obviously here, and we are looking at the straight line that goes, the vertical line that goes directly through 3. Every single coordinate on that line has an x value of 3. There, 3, 3, 3, 7, 3, negative 7, 3, negative 11. All of the points, whichever point on that line you choose, would have an x value of 3. The y's values will obviously change as you go up and down the line, but the x value is staying consistent. I think I meant to put -4 there. I don't really want to draw one right next to it. X equals -4 then obviously is the same kind of thing, but going through -4 on the x-axis. So it would look like that. And again, every point on that line has an x coordinate of -4. They are -4, 2, -4, 12, -4, -6, and so on. But the x value is consistently -4 no matter where on that line you are. Okay, that means y goes the opposite way. It goes horizontally. So y equals -2 is a horizontal line going through -2 on the y-axis. I'm going to use a different colour. So it would look like that. Now again, that means for every point on that line, the y value of the coordinate is -2. So you've got like -10, -2, 5, -2, 11, -2, 0, -2. All of the y coordinates are -2 at any point on that line. And then similarly for y equals 9, that would go horizontally through 9 on the y-axis and would look like that. Okay, hopefully that is really straightforward. It's just a case of remembering what it is. Ones that catch people out are x equals 0 and y equals 0. So I'm just going to do two really quick last ones just to show you where they are. So x equals 0, for every, again, x is a vertical line. X equals something is a vertical line. The only point where x is equal to 0 is here, right in the middle. A vertical line going through that is actually the y-axis. So it's kind of counterintuitive. It's not what you expect, but when you think about it, it kind of makes sense. But the line x equals 0 is the y-axis, because every point on the y-axis, x is equal to 0. It's a really important point that actually you use quite a lot when you are working with straight lines, you have to remember that at any point on the y-axis the x value is 0, and we actually use that a lot to answer questions. And then obviously the other way around, is equal to 0, use orange, is the x-axis. At every point on the x-axis, y is equal to 0. So the x-axis has the equation y equals 0. It's kind of the opposite to what you would expect. You kind of want it to be, well, the y-axis would be y equals 0, but it's not, because the y-axis is where all of your y numbers are. The y number is changing. It is the x value that is staying the same. The x is equal to 0 on the y-axis. Okay? So that's your horizontal and vertical lines. That should be the easiest part. Where it starts to get trickier is when you have a line in the form y equals mx plus c. You need to be able to use the gradient and the y-intercept to be able to plot that line. Again, if you really wanted to, if you really struggle doing it, you could use a table of values. You would put x values at the top. Just choose a few. You don't need more than 3 or 4 really. So say I have -2, say I choose 0, 3 and 5, just to spread them out. I could choose any numbers I wanted as long as they fall on the x-axis. Obviously it wouldn't make sense to use like 20 because that comes off my x-axis, but you could pick any of the numbers you wanted on your x-axis to put into the equation. To get your y numbers, you're using the equation y equals 2x plus 3. So you're doing the x value multiplied by 2 and then adding 3. So if x is -2, 2 times -2 is -4, plus 3 is -1. 2 times 0, if we put 0 in, 2 times 0 is 0, plus 3 is 3. If we put in 3, 2 times 3 is 6, plus 3 is 9. And then if we put 5 in, 2 times 5 is 10, plus 3 is 13. So they give you some coordinates and you could plot them. So -2, -1 would be here. 0, 3 would be there. 3, 9 would be all the way up here. And then 5, 13 doesn't actually fit on to my graph. But that's what it would look like. You would join that up with your straight line and kind of carry it on. That's better. You might want to extend it up this way too, so that it fills your graph. Okay, but we want to look at a quicker way of doing that without drawing the table, without filling out the coordinates, and just using the information you've got on the straight line. So using the gradient and the y-intercept. So from this equation, the gradient, which I'm just going to call m, is 2, and the y-intercept, which I'm going to call c, is 3, because your basic equation is y equals mx plus c, m being the gradient, c being the y-intercept. So I'm going to start with the y-intercept, so that means it crosses the y-axis at 3, so it's going to start here. If my gradient is 2, that means for every 1 square I go along, I have to go up 2. And I would kind of plot a few of those, so along 1, up 2 brings me to there, and then just do a few more just to start to get a line. If you wanted to go back the other way as well, you'd obviously have to do the opposite. So instead of going along 1 to the right and up 2, you're going back 1 to the left and down 2. So your next points would be here and then there. And again, do a few of those until you start to see the pattern forming and the straight line forming. So your graph, when you join it up, looks like this. I'm going to just continue it up a little bit, and again continue it down the other side as well, so it looks like that. That is the equation, that is the line with the equation y equals 2x plus c, not 3, not c. Y equals 2x plus 3. That is what it looks like. So you'd start in with the y-intercept, you are using the gradient, going along 1 up 2, do a few coordinates like that, and then join it up to make the line. Okay, I'm going to continue on quite quickly. Obviously, it's more difficult when you have a fractional gradient. So in this question, your gradient is 2/3 and your y-intercept is -6. Okay, so I start in the graph at -6, so down here. And then our gradient is 2, 3. Now, the way I always think of this is my gradient is change in y over change in x. Okay, don't worry too much about my notation there. The triangle just means the change or the difference between two y values. So change in y over change in x. That means the bottom number is my x value, and that tells me how far I'm going along. The top number is my y value, that tells you how far I'm going up. So for this one, to plot the gradient, I'm going, for every 3 I go along, I'm going up 2. Okay, so 3 up 2. So I'm putting my first coordinate there. And then I'm repeating that a few times until I get a few coordinates. Again, if I wanted to go back and plot them in this -x area, I have to do the opposite. So I have to go back 3 to the left and then down 2, and again repeat that a few times until you have some coordinates that you can join up with a straight line. So your line looks like this. Lovely. Okay, I've just realized I haven't put in a negative gradient. So just to make that, just to look at that. So if I have the graph y equals -3x plus 6, to draw a negative gradient, so this time my gradient is -3 and my y-intercept is +6. So I'm starting my graph at 6. If I have a negative gradient, it's very similar, but instead of going along one up 3, I'm going along one down 3. So I go 1 to the right and 3 down and plot a point there. And then again, do that a few times until you get an idea of what the graph is going to look like. When I'm going backwards, so if I go 1 to the left, I have to go up 3. And again, do a few just to get an idea of what the graph is going to look like, and then you can join it up. Oh goodness, that's better. Yeah, like that. So your line y equals -3x plus 6 looks like that. The negative gradients always start at the top of your graph and go down, whereas, so by that I mean it starts up here somewhere and goes that way, whereas your positive gradients start at the bottom and go up. They're obviously opposite to each other because one's positive and one's negative. Okay, we're nearly done. I've got one more question I want to show you. This one is when your graph isn't quite written in the form y equals mx plus c. Now, the obvious way is to rearrange it until it is in the form y equals mx plus c. So you could subtract the x over, and that would give you y equals 10 minus x. Your gradient would be -1, your y-intercept would be 10, and you could do it like that. Or, when it's written like this and you're adding your x and your y values together to get a value, to get an answer of 10, you could do it by substituting in a value of x and a value of y. So the obvious ones to choose are when x equals 0, y equals 10. Because if x is 0, then you've got 0 plus y equals 10, which is just y equals 10, yeah? And then do the same for y equals 0. When y equals 0, x equals 10, because then you've got x plus 0 is equal to 10, so x is 10. That gives you two coordinates that you can plot on both axes. So when x is 0, y is 10, means your graph is going up to here. And when y is 0, x is 10, so it's also crossing the x-axis there. When you've got 2 points, especially if they're quite far away, like these ones are, you get a good idea of what your graph should look like. And you can just join those points up and again extend it where you need to, like that. So that is the graph y plus x plus y equals 10. And we've done that without having to rearrange any equations, just by putting in the values x equals 0 and working out the y, and then doing that when y is 0, what is x, and that gives you two coordinates. So the coordinates I've used are 0, 10 and 10, 0. So basically where they cross both the x-axis and the y-axis, and then join that up. Okay, I hope that helps. Like I say, if you really don't get this, the fail-safe is always to draw yourself a table of values, choose some values of x and work out the corresponding y coordinates like I did. I ripped it off, didn't I? Like I showed you at the beginning of the video. But being able to sketch it directly from the equation makes it a little bit quicker, especially when you are having to do it within another question and it's not the focal point of the question. So for example, when you are drawing inequalities on a graph. Okay, so I hope that helps. Have a lovely day. Thank you for watching and listening.